Hello everyone! Last week I posted the first video of this playlist about microservices in PHP and Apache Kafka. If you haven't watched it yet, please click on the link right here in this post. In this video, I want to focus on communication between services. So in a microservices environment, services must talk to each other reliably, at scale, and without slowing down the user experience. That's why in our project, I adopt Apache Kafka for Message Broker. So first, a brief analysis of what is Kafka and how it was important to compose our Dynadocument application. When we have a deep flow of business logic or a large number of users processing information in real time, your application assumes the responsibility of what is being requested and responded with fidelity and performance. So you could easily build a good monolith and say it's so much easier, and you're probably right. But considering all those requirements I mentioned in the last video, we have to be aware of concurrency and resilience when managing the project. As you can see in the documentation, Kafka is a message broker responsible for receiving asynchronous events with keys and data and storing them in a place available to any services that wants to react to them. As we have three main microservices in this project, plus a fourth one for the audit logs, which I'll talk about later, all the async events are registered in Kafka in the form of the past actions, which we call topics, and the services can choose whether or not to read that information. In our application, we have three topics registered: template requested, template delivered, and audit log sent. Pretty simple. So after drawing your business logic, let's check the code to see how this is happening. For this implementation, I'm using a composer package to handle configuration and Kafka driver for PHP, Matthews Youngs /Laravel Kafka. The package gives you a complete config structure, which you can see at /config/kafka.php. The first config of this driver is the list of your brokers. So to guarantee that your messages are being sent and received accurately, you should plan how many brokers are enough to ensure your services communication. That will depend on how many users are accessing simultaneously and what is the expectation of demand of this app. Back to the Docker Compose file, you can see that I configured 3 broker containers, 1 Zookeeper to synchronize the brokers, and 1 temporary container to create the topics. In that entry point, all the topics are configured with 3 partitions and 3 replications. Instead of using Kafka directly in the use case, I applied Kafka inside an event-driven architecture. That means all the messages are encapsulated as an event and dispatched by Redis, which sends everything to Kafka asynchronously. The reasons why I chose to use Redis as an intermediate queue instead of calling Kafka directly are: number 1, decoupling business logic from Kafka delivery. If I publish it directly to Kafka within the HTTP request flow, the response time to the client could be affected if there was some latency or failure in the connection with Kafka. By using Redis as an intermediate queue, the request only needs to enqueue the message in Redis, which is a fast operation, and the asynchronous worker takes care of sending it to Kafka. If you send it directly to Kafka and it goes down, the message will be lost, or you will need to implement retries manually. Number 3, flow control and automatic retries. Laravel's Redis queue already has native support for retries, backoff, and dead letter queues. This makes it so much easier to handle temporary failures in Kafka without having to reinvent that part. And last but not least, the fourth reason is independent scalability. You can scale the workers that handle sending messages to Kafka separately from the services that process HTTP requests. After encapsulation by Redis, the event is dispatched and listened to the same service, and then it calls the Kafka producer. In this architecture, a single Kafka producer is reused for all topics, but you should understand that it's just how I think the solution, is not a rule. So the producer has this configuration provided by the package, but I totally recommended you to open the Kafka documentation and understand some concepts before configuring this. The topic is the name of the action. The message is the data that you're publishing. The act 0, 1, and -1 is the guarantee of confirmation of the message. Idempotence is the guarantee that the same message will not be read twice. Beyond that, the Kafka.php also has auto-commit set to true to confirm receipt when another service reads it. You may have noticed that in my diagram, a message called audit log sent is shown, but does not appear in the code. I'll talk about event sourcing in the chapter on observability. Now, focusing on consumers, in Laravel they are like comments that will be constantly awake, waiting for specific messages. Each consumer is subscribed to a topic, and all messages of that topic will be listened to, including all the unread data dispatched before. The consumer keeps waiting for a message to arrive in the subscriber's topic, like template requested and template delivered. When a new information comes, the system unwraps the message content and does whatever he has to do. Okay, so in that document, we also have 3 consumers, one for each topic, plus the one for audit log. Template requested consumer and template delivered consumer. Okay, now I'm going to show you how everything works together by making the request via Postman and capturing the messages in the terminal. For this, I'll just put a var dump in the first line of each consumer, open the terminal, and execute the consumers manually. Then we'll see how each step runs. As you can see, initially both consumers are running, but no message is arriving in any broker. Now let's send a request for file generation and see what happens. That's it. Here in the template service, you can see which message just arrived in terminal. The use case handles service application, and then give it back the template for the file service. Great. I think this is all for today. I want to thank you for watching, and this was the second part of .NET Document Playlist, the open source project using microservices in PHP and Apache Kafka. Next episode, I'm going to talk about Kong API Gateway and SSO. So follow me to see what happens next. Give the repo a star on GitHub, and I'll see you next week.